Whoa, there we go. 11 Fridays left to Christmas. That's kind of scary, isn't it? Andrew just said no audio. I think we've got audio now, so we'll just wait a second. It's not an ASV live stream if there's no technical issues. We good? We're good. Welcome to the October AstroTalk. As I just said, when no one could hear me, 11 Fridays till Christmas. Welcome tonight. We come to you live from Mueller Hall again, and our presenter this evening is Mr. Andrew Yen, who's sitting in the front seat there. In August of 2024, ASV member Andrew Yen embarked on a journey to South Africa, where he attended the International Astronomy Union General Assembly, IAUGA. Do they have an acronym for that? Yeah. Do we just call it IAUGA? IAUGA. 2024. At this event, Andrew presented a talk on the significant advances in astronomy education and says, although he got his 6 minutes of fame, he was exposed to so much more at this event, from teaching a class of African students to imaging the formation of a black hole. Did that actually happen? Yeah. My God, that's cool. So learning about the future of robotic astronomy, he even learnt about a field of astronomy he'd never heard of before. So join us as Andrew, as he recounts his journey and shares with us all of his learnings from his grand adventure. Following from Andrew, we'll hear from our very own Bill Stent, the telescope Gent, I think, maybe, or a variation of him, who, if he is here, will share with us what's in the sky over the next month. There are a few housekeeping items. Sea Lake Astrofest is booking up fast. We have 150 people already booked for the Saturday night viewing night alone. So the Sunday night, there are some spots left. The dinner, which will have Professor Fred Watson, Dr. Sarah Webb, Kobe Brown, Steffi Bernard, Marnie Ogg, Simon Good, or Dr. Simon Good, that's booking up fast as well. And so is our Science in the Pub. So if you want to come along to that event, better grab your tickets quickly, because they are booking up quickly. Don't forget, we have the ASV Geelong Show raffle, which you can win. I think it's a 6-inch Dobsonian or a pair of Saxon binoculars, sponsored by Saxon. And before we begin, I'd like to say that in a spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community, and we pay our respect to the Aboriginal and Torres Strait Islander people today. But first, let's welcome Andrew. You've got your mic. Up you go. All yours.
Fantastic. And you can probably hear me. Good. I was actually a little bit flabbergasted when someone invited me to submit a poster to the IAU General Assembly. I'll stand here. The IAU General Assembly. So I sort of knew what the IAU was. I'd sort of read a little bit about the IAU before. And I always thought, yeah, it's pretty big. This is where the professionals all hang out. I'm just a little amateur. So there's 12,000 members of the IAU. I think they've all got PhDs. I was the only person at Cape Town that didn't have a PhD. I'm feeling very inadequate. And their purpose is really to promote the astronomical sciences. So it's a professional organisation. It's about promoting the profession of astronomy, the findings of astronomers, but they also have quite a strong theme there of pro-am partnerships. So have they contacted you yet? No, they should do. So there's a lot of talk about pro-am partnerships. There's also a lot of talk about outreach, partly because if you have a wide pool of amateur astronomers, then some of those will become PhDs and they'll join the IAU, I guess. It's all about astronomy. It's all about promoting the science of astronomy. So that's a pretty big deal. I'm thinking there's the General Assembly is 3,000 attendees, so 3,000 professional astronomers from around the world, all the way across the world, presenting their particular findings or their particular interest in astronomy. So the other thing I'll point out, these are the people who name planets, and they're the people that demoted Pluto. So I started with that thinking, these are the guys that demoted Pluto. It actually was a joke there that you walk around and they say, oh, who can we demote this time? So they saw it as a bit of a funny thing as well. Anyway, how did I get to go? It's just little old me. This is my first observatory. I took a photograph. It still exists. I observe out of tin shacks and fields at LMDSS and look through eyepieces, and maybe I get a camera on things. How did I end up getting an invite to present a paper at the, or present a poster at the IAU General Assembly? I got into teaching, and I got into teaching through astronomy because I'd always been interested in talking about astronomy. I did stuff with the New Astronomers group years and years ago. I did lots of stuff with the junior astronomers years ago. And more and more, I liked being, I call myself the astronomy evangelist. I spread the good news of astronomy. So it doesn't go down well with some people. But I've always been keen on teaching people about astronomy. And I met some teachers, and I was teaching astronomy at my children's school. And one of the teachers there said, Andrew, you're good at this. You should become a teacher. And it was just the right time, the right place. And I became a teacher because I could teach astronomy and get paid to do. That sounds like a good idea. And through the process of learning about teaching astronomy, I met a few people who started teaching me about the new methods of teaching astronomy. And the new methods are all about robotic telescopes and about being able to teach during the daytime and get students to be able to do their astronomy during their daytime classes on a telescope somewhere on the other side of the world, or to program, I want this, if you can take it tonight, that'd be nice, thank you very much, and you get your images in the morning, rather than looking through an eyepiece, getting cold, travelling a long way, all the things that I enjoyed, but it's not the way to teach astronomy. So that's how I got into it. I'm a teacher. I've only been a teacher for 2 years, but I'm really keen, and some of the methods that I'm using turn out to be cutting edge, riding the crest of the wave. So I got invited. Can you present a little poster? Just a little poster, 6 minutes. Oh yeah, that sounds good. Trip to South Africa. How am I going to fund that? That was a little bit of a challenge, but it turns out if you ask, people give you money. So Rotary, Lions, the school gave me a little bit of money as well. So I got funded to go there, which is great. And South Africa is a lovely place. The wines of Cape Town, that picture up on the right-hand side, that's where we stayed, myself and another astronomer from Victoria. It's an ex-prison. So they converted a prison to a hotel. This is in Cape Town. And in the foyer, they've got a photograph of their most famous guest, Nelson Mandela. So I presume Nelson Mandela was locked up in that prison at some stage. And this is the harbour that we're saying by. And in the background is something significant. In the background is that mountain, which was interesting. So I'm an amateur astronomer, so you get into the folklore and stuff of astronomy, whereas the professional is more interested in the data and stuff like that. So they didn't know about how significant this mountain is. Do we know what this mountain is? It's called Table Mountain. It's got a flat top, obviously. It towers over Cape Town. And at the base of this mountain is where John Herschel brought his telescope and he set up his Southern Observatory. And most of the Western telescope work, the initial Western telescope work of those early, I guess it was 1700s, 1600s, 1700s, don't know when, was done by John Herschel, son of William Herschel, who discovered Uranus. But John Herschel was a great in his own right, but his dad had discovered all the stars in the Northern Hemisphere. What do? You go to the Southern Hemisphere, you set up an observatory there, and a lot of the nebulas, I think the jewel box is a John Herschel term. The homunculus is a John Herschel term. So he discovered a lot of those telescopic objects from Table Mountain. And Table Mountain actually has a place in the sky. It's Mensa. Mensa in the sky is Table Mountain. So it was a really significant place, and a really significant place to me. And I told this story to these professionals, and they're all gobsmacked. Oh, I didn't know that. I didn't know that's why I was coming here. But part of the reason why we're in South Africa is because Africa is getting a lot of radio astronomy equipment. The square kilometre array, the meerkat arrays, they're doing a lot of radio astronomy there. And so South Africa is really keen on investing in educating their young people in astronomy. And this is one of the things I got to do while I was over there, because I'm a teacher. I said, can I teach at a school? Can I meet some African kids and teach them a bit of astronomy? So that's not me, that's one of the colleagues that I went with. But we went to this school in the outer parts of Cape Town. 270 kids in this class. I've got 24 I've got 20 in my astronomy class, I've got 24 in my science class. 270 kids in this class, no heating. It was cold. They're all wearing coats. I wish I'd worn a coat. It was reasonably tough conditions for a school, but these kids were so keen. They were better than my kids, because they really, really were keen to learn. They were very polite, and the stuff you're talking to them, he's talking to them at the same level that I would talk to my year 9 and year 10 kids, and they knew what was going on. The difference probably is that they probably won't get the opportunity to use some of the skills that I've been able to pass on. So that was a really great, fun thing to do, but that wasn't the purpose. That wasn't the reason why I came, but it was a good, fun thing to do, and I did certainly learn a lot about teaching. There was lots of science, because there's 3,000 people there, and half of them, no, maybe a quarter of them, have got a paper or a poster, and they will tell you about what they've done. And so there's a lady from NASA is telling us all about all the resources that NASA's put on their websites to learn about astronomy. Well, that one's Cosmic Resilience Building Mental Health Awareness Through Astronomy. I took a photograph of that one. I was pretty amazed by that. Mental health awareness through astronomy. Stellar occultations, we sort of understand what that is. Light pollution. Light pollution came up a lot, as did satellite pollution. Because not only does it ruin our images, because we get all these lines on our images, it ruins radio astronomy. So the radio astronomers are really upset about radio dark. And there was a whole section of the meeting about radio dark and the debates they're having with a wealthy American guy. Dark energy as explored by AI. Okay, I don't know what that was, but there was a whole lot of science. I understood some, I didn't understand some. I didn't understand most of it. There was a whole field of astronomy that I'd never ever heard of before. I thought I would have some idea of what was going on. It was polarimetry, and maybe you guys know what it is, but polarimetry is taking photographs of things with a polarizing filter and measuring the angle of polarization of the light that comes in and forming images from the polarization. And I'm thinking, well, what does that teach you? And what it does is, when you've got these cosmic jets of moving particles, they tend to polarize the light that's coming from those jets. So they can actually image jets coming out of neutron stars and black holes using polarimetry, a new field of astronomy. It's, I thought, probably a field of astronomy that amateurs could get involved in, but I'd never heard of it before. And this guy here, his name's Brian Schmidt, Dr. Brian Schmidt. He is the Nobel Prize winner for the expansion of the universe, the increasing rate of expansion of the universe. And he told the story about how he'd done some tests and he plotted some points and he had a graph and he had 25 points on the graph and, oh, that looks like it's going up. It shouldn't go up. But he published it anyway. And everyone said, oh, look what you found. And he said, did I? I thought, oh, okay, fine. And then he got a call a few years later and I said, oh, you've won the Nobel Prize. And yet the overall theme that came through all of this was these guys are just guys like me. You know, he talked about, you know, how he was standing in his kitchen holding the phone, and I said, yeah, you've won the Nobel Prize. And he's, what's that? So it's good to talk to Brian, but that wasn't the purpose either. Oh, and this is another little aside. While I was there, I'm walking down the street. This young lady's walking with me and a couple of other astronomers, and we're crossing at the lights, and she gets a page on her phone, and there's been an alert of a gamma ray burst. A gamma ray burst is formed when there's or is caused when there's the formation of a black hole. So when you get a formation of a black hole, you get this gamma ray burst, lasts for almost no time at all, but they detect it with the SWIFT satellite. And she's really interested in studying gamma ray bursts. And I'll get her to tell the story of the gamma ray burst that we helped her to study while we're walking down the street in Cape Town. So I was just wandering through Cape Town and I came across May. Hello, May.
Hi.
Tell me, May, where are you from?
I'm from North Carolina in the United States.
And what do you do in North Carolina?
I work for a robotic telescope network very similar to LCO and Photon Ranch, but with the goal of providing telescope access to students for education.
Ah, so you're an astronomer.
Yes, I am.
Tell me what happened on Friday.
On Friday at about 9:30 in the morning, this time, we got an alert from the Swift spacecraft. So it orbits the Earth. It's a NASA spacecraft, and it looks for high concentration of gamma rays. And it could be from different things, but this was from a gamma ray burst, so the death of a massive star that forms a black hole, and it releases extremely high energy particles. And if it comes towards Earth, then we get notified of it, and we get to start observing.
And how long does a gamma ray burst last?
The initial burst is just fractions of a second, but sometimes they have an afterglow, kind of like a fading light around them that can be detected in other types of light, like visible, radio, infrared. And so we were trying to observe that. Right.
And did you?
Yes, actually, we had none of our telescopes could currently see the gamma ray burst, but the first few minutes are very, very important. So instead, we worked with LCO and Photon Ranch, and they had a telescope at Elkin College which could observe, and the sun had just set, so it was perfect timing, and so they were able to have us start looking at the gamma ray burst within 10 minutes of it happening.
10 minutes?
Yes.
So between the time that the satellite detected the gamma ray burst to the time that you were observing took 10 minutes?
Yes, which is really good. And we want to get as much data over the hours as we can. We can typically only see a gamma ray burst for at most 24 to 48 hours after we get the alert from the spacecraft. So we want to catch as much data in there as possible, especially the first few hours are very crucial.
And so how much data did you get?
We had Elkin College observe for about 4 hours, I believe. And then 2 hours later, our telescopes in Perth and Meckering came online. So they were getting data at the same time, but in different filters so we can learn more information. And then we both did follow-up observations later that night in the Americas. So we got some more data then, and we got lots of data between LCO and Skynet, where now we have enough data together to be able to actually say something about it.
Right. And what do you do when you say something about it?
We study how it was fading because it's getting fainter as the light fades away. And we use that to figure out what could have been happening. So maybe it's eating through dust. There's a lot of dust between us and this newly formed black hole. And so it maybe starts out very, very blue and maybe gets more red. And how it changes tells us a lot about what's happening around that dying star.
Fantastic. Okay, so this is pretty exciting because these don't happen very often, do they?
No, and the hard part is that you never know when they're going to happen, and you never know where they're going to happen. And once it happens once, we'll never be able to see it again. So like this GRB, which is GRB 240809A, this is the only time we'll ever be able to get that data. So now that we've got it, there's no more data to get. And if we missed it, we just wouldn't have it.
It's a black hole now.
Yes.
It's a black hole now.
Yep, and all the lights that's fading around it is gone. It's faded out. The system around it is cooling. The gamma ray signature is gone, and so this is the only time it'll ever happen there. We'll never see that one ever again.
That's fantastic.
Yeah.
It's pretty exciting. So you're going to get a paper out to on all the results?
Have enough to say something in getting a paper, and we might even see something very cool. And maybe it fades just like the most standard gamma ray burst ever, but that's still really important information for us. And maybe it'll do something weird. Maybe it'll have some jets that are behaving in a certain way or something. But we won't know until we process all this data, which we're lucky enough to have.
Fantastic. And how long do you think that might take to get a paper out? How long does the process take?
I'll probably spend the next week or two analyzing the data, getting all of the careful brightness measurements and everything. And then we'll probably spend a few weeks studying what the data shows, trying to match the physical situation and form hypotheses about what's happening, look back at the data, look through the literature, and then hopefully we'll have the paper ready to submit in about a month and a half.
Okay. One more question.
Mm-hmm.
Magnitude. We've just learned about magnitude.
Yes.
What sort of magnitude was it?
So when it first went off, the first few minutes that we were able to get on the Eltham College telescope, it was at about 14 and a half magnitudes. And then by 2.5 hours later, when we were observing it in Perth and Meckering, it was down to about 17.5.
Right, so it changed by 3 magnitudes, which is 10 times or something like that.
Yes, and that was just over 2 hours. So these things fade very quickly. And what we expect we'll see in the follow-up data when I get to it is that it will start slowly kind of leveling off. So maybe by the time it gets to 19th magnitude, over the course of a whole night, it will only go down to like 20th magnitude. So it slows, but the initial fading in the first couple hours is usually very quick. And so that's why we need to be on target very, very soon after the burst happens.
Well, congratulations.
Thank you.
It was very exciting, wasn't it?
Yes, it was, especially because it was a huge collaborative effort and we were able to all come together and get something that we'll never be able to get again.
And being an astronomer is an exciting career, isn't it? Yeah.
Yes, I love it. It can be hard and challenging, but moments like that are worth it. When everyone comes together and does something cool.
Well done. Thanks, mate.
You.
Okay.
So I'd never met May before. Isn't it great to meet people like that to just love astronomy? And she's discovered something. And that telescope that she's talking about, Eltham College, is the one that I manage, the one that Tristan uses. It's a 17-inch robotic telescope. It's a good telescope, but it's amateur scale, and we're doing proper discovering black holes.
Andrew, I guess to do that within 10 minutes of alert, that means a high level of automation.
Incredible. So,
You can do that.
yes.
Right.
So that's a really good Dorothy Dix, because the whole reason I went to Africa was to talk about the revolution in robotic telescopes. The fact that you can, from anywhere in the world, get onto a telescope and tell it to do something, and it does it immediately. Within seconds, you can control that telescope. So all you need is the keys. The key is some way of logging into that telescope. And as May described, she uses a network of telescopes around the world, and she actually uses a number of networks. And because I was walking on the street beside her, she used the network that I was associated with as well. So the network of robotic telescopes is the next big thing. We've been doing robotic telescopes for a little while. You can get a mead and you can program it from in your lounge room and get to point wherever you want to go. But networking telescopes gives you a whole lot of extra capability, because you don't have to use the one that's in your backyard. You can use the one that's on the other side of the world where it's dark, or you can use the one in Melbourne that happens to be pointing at the gamma ray burst that you're trying to study. And the same applies to us as amateurs and students and teachers as well. So I found this is my poster. This is my 6 minutes of fame. I did get quite a bit of interest in this, but it was only 6 minutes out of 2 weeks of very, very high level talks. My presentation was that I had spent most of my life getting people really, really enthusiastic about astronomy through looking through eyepieces, and they were, and it was a really, really good experience. But almost none of the people that I showed through a telescope who was say, wow, I can see the rings of Saturn, almost none of them went on to become astronomers or to follow it through as a career or study a course in it. Some did, no, maybe one did. But when the robotic telescope revolution came along, and I just happened to be at the right place at the right time, talking to the right people, and Eltham College, the college that I was working with where my kids were going, bought a robotic telescope. Wow, suddenly we had classes of students wanting to do astronomy. And from Eltham College, there's 2 students who are ex-students now studying astrophysics at Monash. And I'm doing the same with students at Luther College now. None of them have graduated, but we'll see where some of them go. But you get an extra level of engagement because you can analyse data. You can spend a lot more time on it rather than looking through it. You can't deny that looking through an eyepiece is really, really impactful, but it doesn't have the depth of impact that a robotic telescope can have. And you get to do some real science. You can get to real science and an eyepiece too. But this has really changed the way that we can teach. And not a lot of schools are doing it. Very few schools are doing it. And I'm involved in some of that change. And I get to, that slide hasn't worked. That was supposed to be a slide of the world and various spots around the world that have got access to telescopes. And that's that concept of instead of one telescope, multiple telescopes around the world, give students access to multiple telescopes around the world. And there were a lot of people at this conference talking about network telescopes. It seems to be the big thing for professionals as well as teaching astronomers. There were dots there that should have been in Thailand. Thailand's just set up a new network. Africa is setting up networks of telescopes. The Las Cumbres Observatory is probably the biggest one. They have 20 sites around the world where they've got telescopes that anyone can access, basically. The Skynet, that's the one that May was working for. Photon Ranch is the network that the Eltham College telescope is connected to, and the Luther College telescopes are connected to. And over the school holidays, I was up getting another telescope from a site, and that'll be connected to it over in Ballarat. So it's growing at a phenomenal rate. ICE Telescope, an Australian thing, Telescope Live, I hadn't actually heard much about them, but there are quite a few networks around. But the rate of change, this concept of using network telescope is really, really fast. And my last slide is about, okay, that was all about telescope networks. I was really excited about it. I'm already in there in a way, but I was quite amazed about how quickly that's changing. But the other thing that came out was human networks. So for me, the big thing that came out of it for me is these people that I met from all places around the world that I have an ongoing relationship with now. So that dot in Canada, there's a guy there who has decided that there's a couple of journals that probably aren't doing their job as well as they can for astronomers in the future. So why don't we set up a new journal? And it appears that I'm helping him. I don't know how I got volunteered. I put my hand out. So I'm helping him set up a new type of journal for recording astronomical data. And it's going to be a world beater. It's going to be the best journal in the world, obviously. Maybe. A researcher in Africa who was studying the structure of galaxies. So I'm in contact with her. There's a lady in California who has, she has students that, high school students, and she teaches them to measure double stars. There's another spot, that dot over on the east coast of America, that's May. And so I've spoken to May a number of other times, both on Zoom and on emails. There's a guy up in Cardiff in Wales, and he runs the Los Combros Observatory Network. And 2 weeks ago, he and a couple of other guys sent me up to Orange to dismantle a telescope that we're bringing down, and we're going to install in Ballarat. I never would have got an opportunity. I don't get paid for it, but what a great opportunity to pull apart a 20-inch plane wave telescope, pull the electronics apart, and suddenly I'm the expert on pulling telescopes apart. Well, I suppose I knew how to do it, so maybe I am the expert, but I never, if I go back to that early slide, how did that guy with the tin shed get these opportunities? I don't know. There you go. That's my talk. I won't run away.
Yeah. I don't know if I'm on.
You can talk to my chest if you like.
That could be dangerous. Does anybody have any questions for Andrew? I know you had one straight up. Does anybody else have any questions for Andrew? It's a pretty interesting trip, that's for sure. A lot of very cool opportunities.
Yes.
And if you don't ask, you don't get. If you don't put your hand up, you're never going to get the opportunity, are you?
It was partly putting your hand up, and it was partly, I think a couple of people said, oh, I want someone like you to go. And because you'll give a different perspective. I don't have a PhD. I'm an amateur. I'm a guy like you guys. I look through eyepieces and I get cold at night with an 8-inch dob. But I think that brought a slightly different perspective, and a few people just recognise that that's a good perspective to have for professional astronomers as well. And, you know, you've seen that in me, I'm enthusiastic, and so that sort of helps as well. It's hard not to be enthusiastic about astronomy.
It is, I agree,
Yeah,
absolutely.
I think so.
I think one of the best things that we do, a lot of us do, is volunteering our time to do things for a hobby we all love.
Yes, yeah.
It's one of my favourite things to do is volunteer. It's great fun. It's a bit selfish though, isn't it? We get the enjoyment out of it. But anyway, Andrew, you do have a question. Yes.
I was going to say, if no one else is asking a question, I'll steal the microphone. I was just going to ask, if someone was on your telescope, getting a happy snap of a picture, how does someone come and override them? big event. I'm a researcher. There must be some sort of priority system of some kind.
There is a priority system, and if May hadn't been talking to me and a couple of the other guys that run the network, she probably wouldn't have got access. We just kicked anyone off. Actually, it turns out there wasn't anyone on that night, but if there was, then she couldn't have got access without, like she was effectively a nobody up until the time that we were walking down the street together. And then, use that telescope. Fine.
For you.
I think my question got answered just then. So this is great. When she got access to the image, that was just because you rang up. It wasn't automated. There wasn't any technology that knew that camera was pointing there at that time. Like, it wasn't that level of automation, was it?
So the level of automation was that she got onto her laptop. We gave her a code to get into the telescope. In fact, she might have even had a code already, and she already knew that telescope, the roof was open, and she just typed in, these are the coordinates. Oh, so the telescope is robotic. So the telescope reacts to the website that says we want to go here, and so you type in enter, and the telescope moves to that location. Yeah. Oh yes. Yep. Yeah. It's not a by chance thing at all. It's all controlled by the person who wants to do the observing. And they might do 10 minutes of observing, and then someone else comes on and they say, I want to point somewhere else, and they'll get 10 minutes of observing there. Or someone might say, I've got a transit that I want to measure, so I need that particular time. I can't sort of move my time around, and so they get a different type of priority. Or I want an exoplanet or something like that. And so you can change the different priorities that different people have. One of the things that struck me about astronomy, and I still can't work it out, is that when professionals do a project, they get a whole lot of funding from a university or from government or whatever. They build an observatory, they measure a whole lot of stuff, and then the project's over and they get a promotion or something, and then the telescope's left and it's looking for jobs to do. So these networks are incredibly expensive, but they all seem to be funded. So all of the telescope work that I've done on networks, and the work that May did, and the work that Tristan does, it's all free. I don't know. I came from a commercial world where you had to pay for everything. You don't seem to have to pay for telescope time. As long as you're prepared to use telescope that someone's used before, you can get free telescope time. And that applies to you guys as well. If you come and ask me for a code, I'll give you a code and you can use these telescopes.
I'm going to ask you for some codes.
Okay.
I want to have a play.
Yeah, a play is what you need to do, because they take great images. You can buy a sea star and put it in your backyard. They take great images as well.
They do.
But if you had to play with a 17-inch or a 20-inch or a 1 metre telescope, that's dream stuff, isn't it? I think it's dream stuff.
Oh, look,
My wife doesn't have the same dreams as me.
look, I use phones, as you know.
Yes.
And I've always said I'll never buy a proper camera, but I would love to have a go of something like that.
Yeah.
So, yeah, I think if anyone is keen, I think we should all hit him up for some codes. We do have another question.
Thank you. I was just wondering, if it wasn't for our telescope, would they have another telescope to have used? Around the
No, they
world?
would have missed it.
So fortuitous. Otherwise, everyone would have missed it, because Australia was the only place that was actually in the right
That's right.
position at night to pick this stuff up.
Yep. They had a telescope at Siding Springs, and it was clouded out. So Can you believe Siding Springs was clouded out and Eltham was clear?
It's usually the other way around. Did you? Yes, we do have questions.
You've got to get your shat on the network.
So obviously, this was a case of me being in the right place at the right time,
Yes.
you being in the right place at the right time, and your colleagues.
Yes.
But this has clearly sort of proven and shown that there is an opportunity for international collaboration, and maybe it's already
Very much so.
happening.
Yes.
But some sort of an arrangement of sharing these telescopes and building those relationships and being able to tap into it, because, and I don't know how it works with writing papers, whether it's, whoever gets that notification. Gets
Apparently
all
my name's going to be on her paper.
There you go.
So
Is
you
there
go.
any, and I was curious,
And all I did
when,
was walk down the street.
yeah, when did this happen? Are any of the photos available or not yet?
I haven't seen them. I
Okay.
did write to her a few days ago and she hasn't replied. So
Okay,
So
okay. But
she-
it sounds like it's a great opportunity for some international further collaboration.
And I think you've hit on something important there, that we as amateurs think about our backyards and maybe LMDSS, and we think about our telescope that we bring out, or our mate's telescope, whereas the professionals have this sort of global view, and they're saying to us, why don't you have the same global view? Because it doesn't actually cost you any money. You give away some of your telescope time in exchange for somebody else's telescope time, and everybody wins.
What do they say? Sharing is caring.
Sharing is caring. And astronomers are very sharing people.
They are, yeah.
Yeah.
They're friendly as well. So.
Yeah. Oh, well, I'm not, but
I beg to differ. Any more questions for Andrew? No. Well, Andrew, thank you very much. It was very, very interesting. I loved listening to that video with how she explained how everything happened. That was great.
she was very inspiring. I met a lot of inspiring people.
And I'm guessing you've shown the school kids that video as well.
I have, yes.
Yeah, they would be very excited by it too.
Yeah.
Did I see on there 67 students doing astronomy?
Yes, I've had, so at Luther, I've had 45 students. And through Eltham College, I've had probably, I don't know when I think, 25, something like that. Yeah, so that'd be about right.
So you're talking
Yeah.
about 90 students?
Yeah.
I don't know, 70 students?
Yeah, something like that.
Wow, that's impressive.
And that's come out of being able to do it robotically. When you do a night sky session, I love doing night sky sessions. Everyone gets the wow, but you don't get students out of it.
Yeah.
Interesting.
All right, well, thank you very much. It was great to have you on.
That's no criticism of the fantastic. I've looked through telescopes with you, and I love it. But I've just seen there's another way as well.
There is.
Yeah.
And we need to explore it.
Yeah. Good.
Thanks for coming, Andrew. Good to have you. All right, now I'll get you to take your laptop.
I got to
because
get rid of that. You want to?
The Bill Stent imposter is about to arrive because Bill's not here, but he did send me his slide presentation. So you have to put up with me doing Bill Stent, the telescope Gent. And I thought I'd get in costume as well. I'm taking a cue from Ken's. And I got a Bill hat because you can't do Bill Stent telescope Gent without a Bill hat. Bill's actually sunning it up down at Phillip Island at the moment, commissioning a telescope. So this won't be anywhere near as good as Bill's, but we'll do what we can, hey? Oh. Do I have to share it or will it share it automatically? It's getting there, isn't it?
You got it in presentation mode?
About to now. He's now in presentation. Here we go. I can't do a Bill voice, sorry, but this is Mark Stent, the telescope gents, what's in the sky for late October and early November 2024. And as Bill would say, we are on the lands of the Bunurong and Wurundjeri people, the Woiwurrung peoples of the Kulin Nation. General sky conditions at this time of the year, they've been pretty good lately, haven't they? Pretty good. Well, we've got 4 clear nights in a row this week. So the conditions have actually been improving as opposed to the last, 9 months of horrible cloudy weather. Colin knows what I'm talking about. We've had to give a few tours in pouring rain. What's in the sky? This is what we're going to go through. What's in the sky? We're going to go through things to look out for this month. Now, general conditions. Welcome to Australian Eastern Daylight Time. That was fun, wasn't it? We all lost an hour's sleep on Sunday morning, and I went to bed at 4 o'clock, which means I went to bed at 5 o'clock. That hurt. To adjust your go-to hand controller, you do not need to change the time zone. Just set the daylight savings setting to yes. That's important. That is very, very important. And Handbox will figure the rest. You know what I didn't do on Sunday night and last night? Set the hand controller to daylight savings, yes. And I was wondering why it wasn't polar aligning last night. Now I know. What's he actually? He's got an actually. Evening maps will be 10 p.m. from now on. Morning maps still 5 a.m. You know, he's given me no notes other than give me the slideshow. So sunset about 7:32 p.m. Dark from 8:30 next month, 8:04 p.m. Sunrise will be at 6:44 a.m. and dark until 5:45 a.m. and next month 6 a.m. So even though it's getting darker later, it's getting lighter later. So for young astronomers, we're going to talk about what is a comet, why does it get a tail, and are there really two tails? Why do we make jokes about daylight savings? Can it, slip back. Can it fade curtains? I don't know what I'm doing there. We'll go back. We've missed it. Sorry, we're jumping forward now. This month's moon, first quarter is on Friday the 11th, which is 2 days from now. So is it going to be clear at Melbourne Observatory on Friday, Colin? I think it is. Yeah, it looks like it's possibly going to be clear. And if it is, Colin will have the moon up in first quarter for members' night. So rises at noon, sets at midnight, and the waxing, then following the week is a waxing gibbous, crosses to the north on the 16th, so it'll be low in the sky for the next fortnight. The perigee is on the 17th, and the full moon is on Thursday the 17th of October. It is a supermoon because we are close to perigee and rises at sunset and sets at sunrise. Poor viewing due to direct sunlight. View all night now and over the following week in the morning as a waning gibbous. My messenger's going off. People are messaging me who are watching this and probably laughing. Last quarter is on the 24th of October, which leads nicely into Sea Lake Astrofest. Rises at midnight, sets at noon, and then over the following week as a waning crescent, it gets thinner and harder to see as it approaches the sun. View in the morning, then later this week in the early afternoon. And it crosses to the south on the 29th, so it'll start to get high in the sky from Melbourne. The apogee is on the 30th, and the new moon on Thursday, the 3rd of November, just in time for the long weekend for everybody to go away and do 3 or 4 or 5 nights of astronomy under dark skies. Close to apogee, so it's a mini moon, and it's close to eclipse matching declinations, but not quite. I remember Bill talking about this last month. It rises at sunrise, sets at sunset with the sun, which is again good for us. Waxing crescent is very thin, but able to see in a few days at sunset. Look west. And the first quarter is on Saturday, the 9th of November. Bill, he loves his lunar X. When is it? He's visible this month on Sunday, the 9th, actually the 8th, okay, 11:49 p.m. on the 8th, if you can stay up that late on a Saturday night. Crosses to the north on the 12th. The planets over the next month. This is from the ASV yearbook, courtesy of Jim Katsoufolis. Thank you, Jim. Mercury is an evening object now in the west, rising out of the twilight late October. Next greatest elongation is mid-November. Venus is very bright still. It is extremely bright. We were looking at that through the scopes at Melbourne Observatory on Monday night with our attendees, and they were loving it. Is an evening object that sets at 10:15 p.m. I will say it's very hard to find through trees just as it's setting. Mars is finally moving now, rising at 2:45 a.m. It'll continue rising earlier, giving us more observing time and moving to retrograde in December. And all our lunar and planetary guys will be happy about that, give them something else to image. Jupiter rises ahead of Mars at 12:40. It'll be consistently early until opposition in early December. Retrograde starts yesterday, the 9th of October. So it'll brighten noticeably. And Saturn rises well before sunset, still in retrograde. Rings are close closing. He's got there March 2025. I've been using Bill's date of March 2025 when we do our tours, so if he's wrong, that's embarrassing. In great position now for evening viewing, a premier object for observatory tours, and it is. They have been loving looking at Saturn lately. Uranus rises late in the evening ahead of Jupiter, setting after sunrise, so good morning viewing. Opposition is in mid-November. I'm going to try and image that with the sea star. I'll give that one a go. Neptune rises before sunset, an overnight object setting before sunrise. We're after opposition, and it's following Saturn. And Pluto, why is Pluto on here? It's not even a planet anymore. Rising about 1 p.m, sets about 3:45 a.m. Good evening object if you can find it. If any of you can find it through a small telescope, you've got Superman's vision. Good evening object if you can find it. Yet retrograde starts on Saturday, the 12th of October. That's this Saturday. So it'll be especially slow as it stops and reverses. That's another one I've seen some people do with the Sea Star. Again, I'm talking about robotic telescopes, and I've seen some people do that over a few nights. That's one I might give a try over this coming weekend, actually, see if we can get it. I'd love to do it with my phone as well, actually. That'd be pretty cool too. Getting orientated. Sky at 10 p.m. facing south. I've never seen the clock in the sky. Okay, so we've got the Southern Cross at about 4:30 on the clock, low in the south-southwest. Whoop, oh, there, that's better. Now no one can see me, that's even better. Scorpius is near the moon, moving west, but still no Orion, not unless you're a night owl like me and you're up until 5 a.m. Orientation of stars, a curving line from south-southeast to north-northwest. That's actually pretty cool. I've never noticed that, and now I'm going to go looking for it. Thank you, Bill. Canopus is low in the south-southeast. Achernar is high in the southeast. Fomalhaut is slightly east of the zenith. Donut warning. Do we know what the donut warning is? Yeah. Yeah, Dobson's hole. Altair is halfway from the zenith to the northwest location, and Vega is very low in the northwest, maybe in the trees. For most of us, it probably would be. Antares in Scorpius is lowish in the west. Scorpius season is nearly past. I did manage to get a few more hours on Eagle though, so I was very happy with that. Saturn is highish, slightly north of east, but don't orient yourself with a planet. Oh, Bill's visual targets for the evening, sky at 10 p.m. Venus, so he's got naked eye, binoculars, small telescope, setting at 8:15 in the southwest. Albiro, double star, he does love his double stars. Small telescope, high magnification telescope. I know he gets that one up in the Troughton and Sims a lot. The coat hanger asterism. What's he got here? Binoculars and a small telescope. Wild duck cluster. Binoculars and a small telescope. Yeah, I'm not going to say that because I'll get it wrong. Binoculars, small telescope, and naked eye. Saturn. George Swab, what an image, George. Thank you for letting Bill use that image. It's probably the first time George is finding that out. But it is a nice image, that one. Small telescope and high magnification telescope. Eridani, the cat's eyes. We were looking at this the other night. This is a good one too. Small telescope and high magnification telescope. And Beta Tucanae, which is already got a small telescope and high magnification. And Eridani, Achernar double, another one with small telescope and high magnification telescope, and a small Magellanic Cloud, naked eye, binoculars, large aperture telescope, and a small telescope with 47 Tucanae, which is a beautiful object. NGC 362, that other glob near the small Magellanic Cloud, which is always a fun one to trick people and say that it's 47 Tuc when it's not. Mesarthim is a double star, a small telescope and high magnification as well. And I think he's got some images. And Marie with the Triangulum Galaxy, Veil Nebula from Rick Zhang, Helix Nebula, Sculptor Galaxy with NGC 288. That's a nice framing, that is. Nice framing, Bill. We've got NGC 1365 and the Fornax cluster from Russell, another one of Russell's amazing images. And 47 Tuck and the Small Magellanic Cloud from Jeff Healy, and some astrophotography that Bill does not know that I snuck into his slideshow. Sky at 5 a.m. facing south. Note, it's not all that different from last month. Welcome to Daylight Savings. Southern Cross at about 8:30 from the South Celestial Pole. I saw that rising in my time lapse from this last night. It was quite interesting to see it rising over Melbourne from Coburg. That was cool. Orion is approaching the meridian. Planets are starting to spread out. We have Saturn starting to set. Neptune also starting to set. Uranus not far from the Pleiades. Jupiter is approaching the meridian, and Mars is starting to move. It's a great opportunity to check out the crosses in the area. There's a lot of crosses there. We've got the Southern Cross, the False Cross, and the Diamond Cross in there. But wait, what about Comet? Comet Tuchinson Atlas. It's been great over the past couple of weeks, but then went in front of the sun. I was lucky enough to see it from the top of Mount Buller at 5 a.m. Thank you, David Rolfe, for making me get out of bed. It was well worth it. It really was. Just about to emerge now, about the 11th. If you're clever, it'll remain an evening object from now. Look slightly north or west of west and just after sunset. It will continue to move up and right, easier to see, fading over the next couple of weeks, harder to see. Consult your planetarium app. This shot is 16th of October at 8:10. Use the altitude of Venus as a road sign. You're still going to need to be pretty high to see this. Sorry, one of my shots slipped in there again, Bill. That's from the top of Mount Buller. All that light pollution there is Mount Buller, with nobody at Mount Buller because snow season is finished. So for a very, very small town with a population of 0 over the summer months, that's not good. Not good at all. But that's a nice shot of the comet. That's a beautiful comet, that one. It's very nice. But wait, what about T Corona Borealis? Bill needs to go to Corona Borealis Anonymous. He's slightly obsessed with this thing. We spent a long time watching it, doing nothing. No, Bill, you spent a long time watching it and putting us through it. Looks like the sun will get in the way before it goes off, but the light curve is trending down again, not an indication of anything. You see his light curve going there nicely. Perhaps we'll get to see it go off after all. Bill's bet is not. Final notes and random observations. The 12th of October, Pluto moves into retrograde. The astrologers will go nuts. On the 15th of October, Moon and Saturn are close to conjunction at 4 a.m. About the 12th of October, Tuchinson Atlas will become visible in the evenings. He's got his dates wrong there. He should have put that one in front of the 15th. Amateur Bill. 28th of October, perihelion of sun-grazer comet C24S1 Atlas. Will it survive? That's a good question. I've heard some people talking about that. 5th of November, US election, the genesis of much of astronomy was astrology and prognostication. I think that could decide whether we see anything after the 5th of November or not, depending upon who wins, eh? And the 8th of November, Lunar X at 12:49 UT or 11:49 AEDT, lowish west. Sources, Stellarium, Sky Safari. You can all read those. Thank you for joining Mark Stent, the telescope gent. I better not leave the hat behind. That was a wonderful talk, Mark Stent. Thank you.
Can I do a lone telescope ad?
Yes. Come on up. We're going to do a lone telescope ad. Impromptu.
Hi, my name's Kenley Marquand. I run the Loan Telescope program. It's coming up again to loan in about a month's time. There are lots of telescopes available. So if anyone's online and is a member of the ASV, just log in, head for the loan telescope page, and you can book a loan telescope. Get it for 3 months, $80 down, $50 back. It's an 8-inch Dobsonian telescope. So it's a decent telescope.
It's not a 10-inch like that.
It's not a tenner, no, but it fits in your car.
So does that just.
Depends on your car.
Nothing
That's why
else
we
in your
went
car.
8s. But yeah, thank you.
You're welcome. I'll send it out in Crux Extra tomorrow. Do one just for that. Yeah, there we go. Thank you to Andrew for giving us a talk tonight. Thank you to Mark Stent, the Telescope Gent, for his presentation. Thank you, Ken, for letting our members know about the Loan Telescope program. I'll get an email out tomorrow for everyone. Yes, there is a 10-inch Dob hiding over near the camera over there, which was graciously donated by an English tourist who bought it brand new about 3 or 4 weeks ago, used it, and now he's going back to England and said to the ASV, would you like it? And we said, yes, sure. So that's going up to Heathcote, courtesy of Gavin, as a door prize for the Christmas barbecue. It's got eyepieces, viewfinder, it's brand new, it's hardly been used. So yeah, lovely donation by him. As I said earlier, Sea Lake tickets are booking up really fast. We've got the Geelong Show raffle. Link is on the website. There is a possibility that we might be doing an impromptu live stream on Saturday night because we've had some members ask about it. Yes, Gavin?
Is there an ASV stand at the Geelong Show?
There is an ASV stand at the Geelong Show, and it would be manned all weekend. So if you're not doing anything, not this weekend, but the following weekend, ASV Geelong are setting up at the show. See, will be there, I'm guessing. On the Friday, others will be there. Kelly and Hugh will be there. I'm going to pop down on the Sunday. So if you've ever wanted to go to the Geelong Show, go down and say hi to the guys at ASV Geelong. They'll show you around the club rooms, and you might win a telescope as well. So yeah, tickets on the website for that one. It's clear outside, so I'm sure Colin's going to go and set the scope up, the 12-inch in the Astrograph house after he's had a bite to eat. We're all going to go and have a bite to eat and then go to the library as well. We'll see you next month. Oh, next month we have Annie Handmar, an astrophysicist coming down from Queensland. It'll be the week earlier because the night that we're meant to have the AstroTalk is her 30th birthday. So I said, you can stay home with your family and we'll do it a week earlier. So it'll be, I think it's the 9th of November. See you next month.